Dear students, Assalamu alaikum. Lastly, we were dealing with the properties of three states of matter, that is solid, liquid, and gas. We already dealt with the internal picture of solid, that is arrangement of constituent particles in solids and liquids and gas. Now, in this video, we will differentiate solids, liquids, and gases with reference to arrangement of constituent particles. Means what property that solid, liquid, and gas possess. First, what we find? First, we find solids. They possess a definite shape and definite volume. Means what it means, solid is possesses a definite shape and definite volume. Means the shape of solid is definite. Definite means which can't be changed. They possess a definite shape and definite volume. Their volume is also fixed. They can't change their volume. They can't change their shape. Means their shape is definite and their volume is definite. This property can be attributed due to the fact that in solids the constituent particles are closely packed together and they are held together by strong binding forces, and these strong binding forces does not allow the constituent particles to move. It is because of that the shape of the solid is definite. But if you take the example of a liquid, they possess indefinite shape and definite volume. Means the shape of the liquid is not definite. Rather, liquid takes the shape of a container, takes the shape of a container in which you fill that liquid. Means if you fill the liquid in a glass, it takes the shape of a glass. If you fill the liquid in any other bowl, it takes the shape of that bowl. If you fill the liquid in a bucket, it takes the shape of a bucket. Means its shape is not definite, it undergoes a change in shape. It is again the arrangement of constituent particles, that is loose type of arrangement, and molecules can flow from this side to this side. Means they can change their shape. Means their shape is not definite, rather their shape is indefinite, but their volume is definite. What it means, their volume is definite? Their volume is definite means if it if it takes a what we call as a space in glass, volume is space taken by any liquid. If it is 10 ml or 10 centimeter cube in another container like a bowl, it again takes the 10 centimeter volume, 10 centimeter cube. Means by dipping, by changing the container, its volume will not change, rather its volume is fixed, its volume is definite. That is, liquids possess a definite volume but indefinite shape. But if you take the example of gases, in gases what you find that gases have indefinite shape and indefinite volume, both indefinite shape and indefinite volume. What it means, indefinite shape and indefinite volume? It means that gases don't have their own shape. They take the shape of a container. If you fill the gas in any what we call as a cylinder, it takes the shape of that cylinder. If you fill this gas in any other container, it takes the shape of that container. And second thing is they have got indefinite volume. Gases don't have their volume, they take the volume of the whole container that should be available to them. If you can, that is later on we will deal. We can compress the gas, we can expand the gas. What it means is compression and expansion. It means increase and decrease the volume. If you take the piston, if you fill the gas in this container and there is a piston, there is a piston, if you take the piston up, what happens, the volume will increase. If you fill the piston down, the volume will decrease, means expansion and compression takes place. It is again, this property can again be attributed due to the arrangement of constituent particles. The constituent particles are as far as clue as possible, as far as what we called as and there are weak interactions, almost zero interactions between the what we called as these molecules. Second property is that solids possess rigidity. They are rigid in nature. Why they are rigid in nature? They are rigid in nature because of the close packed arrangement of constituent particles. The constituent particles are closely packed together, and constituent particles are as close as possible. They occupy the maximum what we called as the space available to them, and they only leave some what we called as vacant spaces. They leave some vacant spaces, or what we called as interstitial spaces between the constituent particles. And this close packed type of arrangement between the constituent particles provides the characteristic property to what we call as solids, that solids are rigid in nature. They are rigid in nature. If we apply the citrus to them, what we can't deform their shape, we can't change their shape. They apply the same force in the backward direction, means they are rigid in nature, they possess rigidity. And if you find the third property in case of a solid, they are incompressible. Incompressibility. Incompressibility, we can't compress them. If we apply the force, we can't compress them. Why we can't compress them? We can't decrease their volume. Why we can't compress them? It is again the arrangement that constituent particles are already as close as possible. If we apply the citrus to them, we can't bring them much closer because they are already as close as possible. These are the properties of actually what we call as